Alright, so hello everybody, and I want to start making some videos for chapter 4 here. And chapter 4 is a real important chapter regarding the time value of money, okay? And basically the time value of money basically tells us if we're going to evaluate a long-term project here, right? Such as an investment in R&D, we need tools that allow us to compare cash flows that occur at different points in time. We develop these tools, and this is the chapter where we're going to really develop these tools, and we're going to look at the concept of net present value. And the net present value is going to express the net benefits of the project in terms of cash today. All right, and we're going to look at shortcuts. We're going to talk about annuities. These are important terms. Perpetuities and other special cases, okay? So we're going to look at all these concepts with regards to the time value of money and the streaming of cash flows. And it's important you read this chapter very carefully, okay? And I don't know why that does that all the time. All right. So first of all, we look at a timeline. And date 0 is always considered today. And when we start doing net present value, the cash flow out of your pocket that you invest at this point will be negative. So this is showing us our stream of cash flows. Here's where we invested our money, and here's where the positive values are coming in. So this is a stream of cash flows, and this overall is called a timeline. So date 0, again, as I just said, represents the present date, right? That's the present, that's today. Date 1 is 1 year later, and the end of the first year, and so you can see we had $10,000 the end of year 1, okay? All right, so in this example, both cash flows are inflows because they're positive. Everyone notices that, right? Positive 10,000. And here's what I was just talking about. If you look here, here's if you invested 10,000 out of your pocket. Is everybody clear? 2 positive cash inflows, 1 negative cash outflow. Notice that the first cash flow at date 0 is represented as minus 10,000 because it is an outflow. Okay? All right, so this is a timeline, and this is the concept we're going to use. And there's a simple example here of constructing a timeline. All right? All right, so you're going to pay your tuition here. Here's just an example, $10,000 per year. And this is semesters, right? So you're going to pay every 6 months, what, $5,000, I suppose? Every semester you're going to pay. So here's negative cash flows going out. So that's another example. So here's a timeline of equal installments of paying your tuition every semester. All right. All right, so there's 3 rules of time travel we got to worry about here. And the first rule we're going to talk about, it is only possible to compare or combine values at the same point in time. All right, so that's the first rule of time travel. All right, and this was introduced in chapter 3. All right, and this is where the concept of present and future value come in, and we'll go over that. All right, rule number 2 states that moving cash flows forward in time. So let's look at rule number 2. Do they say what it is here? But basically, our second rule stipulates that to move a cash flow forward in time, you must compound it. Okay, forward in time is the direction of the arrows. So we can apply this rule repeatedly. Okay, so you can clearly see on $1,000 you're getting 10% each period, and it's growing and it's compounding. Okay, and what's the time value of money? The difference in value between money today and money in the future. Also the observation that 2 cash flows at 2 different points in time have different values. And compound interest is the effect of earning interest on interest. So, okay, so all right, so here's a table that basically a graph, And this is the composition of interest over time. Here's your initial deposit. All right, and here's the simple interest on the original deposit. You can see this green is the simple interest on the original deposit, and this is the interest on interest. Okay, so this graph shows the account balance and the composition of interest over time when an investor starts with an initial deposit of $1,000 and in an account paying 10%. The green bar shows the effect of simple interest, interest earned only on the initial deposit. The blue bar shows the effect of compound interest, where interest is also earned on prior interest payments. All right, over time, the effect of compounding is more pronounced, and by the year 20, the total amount of simple interest earned is only $2,000, where interest on interest is $3,720. Okay. So you only make one payment in this case, right? An original one-time deposit, all right? So you can see this nice simple example here where they do a nice simple calculation. 7 years, you have $1,000 in an account. How much are you going to have in 7 years? And they show, here's the 7-year account. And here's the 20-year account. And here's the 75-year account. So an interesting concept is your money's going to just about double. If you get 10% in 7 years, your money will just about double. And I believe I sent everyone a paper called the Rule of 72s. And if you don't have you not done so, please Google or look up about the Rule of 72s and how that will affect the growth of your money. Okay? So I think that's definitely worth doing. All right, so Rule 3, and here's Rule 3 now. And what does that stipulate? That to move a cash flow back in time, we must discount it. Okay? We must discount it. All right, so, and here's what I was just talking about, the Rule of 72. So please go over this and understand what they're saying here. Any combination of two numbers that come out to 72 approximately doubles your money. Okay? So I just want to make that clear. So here was the second rule of time travel here, right? And basically we're bringing everything back to the present. So here's $1,000 in the future at 10%. And what's the present value? And as you know, we can use Excel for this. So here's the present value of a cash flow. Okay, here is the present value of a cash flow. And there's a nice example here, a nice simple example, which I think we may have gone over this already, of the present value of a bond. Okay, if it's $15,000 in 10 years in the future, what is it? What would you pay for it? How much would you pay for that bond today? All right, so let's go through this here.
In this problem, we need to determine the market price of a savings bond today if the bond will pay $15,000 in 10 years' time and the competitive interest rate is 6% per year. We begin by sketching out the timeline. In this case, if we hold the savings bond, we don't receive anything until after 10 years when the bond matures and we receive the $15,000. How much will this bond be worth today in a competitive market? Well, this is the same as asking, what is the present value of the bond today? The present value is the amount of money we would need to invest today at the current interest rate to receive the same amount in 15 years' time. Given the interest rate of 6%, we can compute the present value by discounting by 1 plus the interest rate 10 times, or to the 10th power. That is, we take $15,000 and divide by 1.06 raised to the 10th power. Calculating this, we get a present value of $8,375.92. In other words, investing this amount at 6% interest would grow to become $15,000 after 10 years. Because this is another way to obtain the same payoff as the bond, by the law of one price, This must be the competitive price for the bond today. That is, the market price for the bond should be $8,375.92.
Okay, so I hope everyone was clear about that. So now we're going to start applying these rules of time travel, and we start again with a timeline, and here's the timeline, and here's the future value after, of the money growing, right? Now we're making payments, so we have $1,100 on the first initial, and then we pick up another 1,000 here. So we make a deposit, and then we start making annual deposits here. So this is the total in the bank, so everyone sees that, right? And I hope everyone's clear as we keep putting $1,000 in the bank every year, and that the interest is growing. Interest on interest is growing. So you can see the total amount we're going to have in the bank at the end of year 3 is $36.41, which is right here. Okay. And so there's many ways of doing this. We can do each year separately and then add them up at the end. You see, this is the second approach that we can use. Let's do this for 3 years, this for 2 years, and this for 1 year. So we can do that. So here's the 3 rules of time travel, okay? And it's important that you understand and know this. If you don't, please email me. And here's the equations for Rule 2 and Rule 3. This is the future value equation. Again, this is in Microsoft Excel, so you don't have to really worry about it if you know how to use Excel. And here's the present value in Excel. Okay. If you have any questions on this, let me know. Okay. All right. So now here's a nice example. Please go over these examples. All right. So I'm going to stop on this, and I'll pick up over here. Okay.